And someone just asked about this. So if we want to do a three-dimensional array, Numpy supports that, so we can just specify, we want this to be 3. So we can specify 3 dimensions or 4 dimensions, and it will just use these brackets, this kind of bracket notation, to keep adding more dimensions.
So it generates everything as a float. So if you have integers, does that mean you have to like make them a float to interact? Since you only have one data type.
So you can specify, like here we can specify d type equals integer.
Oh, right. Okay.
So you can't have mixed formats. So and I mean by default it uses float because that's more flexible, but integers are more precise. So if you're only ever going to have integers in your array, then you can just specify up front when you create it that the data type is integer. So indexing and slicing is the next topic I want to cover. So depending on the number of dimensions of the array, you can specify that that many dimensions to get an index or to get an element out of that array. So if we want the first element of v, which would be index 0, that's going to be just v bracket 0. Since M is a matrix or a two-dimensional array, it takes 2 indices. So if we want that first, well, rather this would be actually the fourth item, or the row 1, column 1, which is actually the second row and the second column, right? Because we're always counting from 0. So that we made that matrix 1, 2, 3, 4, and then we changed it to 5, 2, 3, 4. So that last element in row 1, column 1 is 4. So if we go up here, we can see that. Yeah. So row 1, column 1. Sorry, row 1, column 1 is here. And if we just specify the one index, we're going to get the whole row. So this would be row 1 and nothing and no other arguments. So we're going to get row 1, which is the second row. So it's 3, 4. We can specify that explicitly, which is safer, because then you kind of you're making it more explicit about what you want. You're saying I want row 1 and then all columns. Or you can say I want all rows, column 1. And in either case, you're going to get a one-dimensional array. It's going to look like a row because a row is one dimension is rendered as a row. But how you think about it physically is not important. It's how it's stored in the machine. So row 1 is 3, 4. Column 1 is 2, 4. And again, we can assign elements using these indexes. So we can say I want to set that first element 0, 0 to -1. And we can also do this for whole rows or whole columns at a time. So here I can set this first row, row 0, as all 0. So that -1 and 2 are going to be 0. And then I can set the column 1, so this is the second column, to -2. And so now, I changed this to 0, but then I changed this to -2. So this is what we're left with. So indexing is what we call when we pull out typically a single item. We had some kind of slices here thrown in there, but a slice is when you get a range of items. So actually, technically, those were indexing. They were just indexing to pull out a whole row. But with a slice, we can get a range of items. So we're going to say we're going to make an array that has elements 1, 2, 3, 4, 5, and then we're going to slice out from position 1 to 3. So remember, this is giving us, this is position 0, 1, 2, 3, 4. So we're going to get from 1, 2 to 3. So this should have 2, 3 as the output. So this is giving us this slice from the start to the end, but not including the end. So when we do any kind of positional slicing like this, we always get the first element, but we don't get the last element that we've specified, because we've seen some reasons why this helps. But another way you can think about this is that going from 1 to 3 is, 3 minus 1 is 2, so that slice should have length 2, and it does. So we can set a part of a slice to be changed using the same kind of notation. So we can say we want slice 1 to 3 to be set as minus 2, minus 3, and now we've changed the slice there. So technically, slicing has 3 components. It has a start, a stop, and then a step. And usually we leave the step out, but we can put the step in. So if we just leave all of those blank and we have just 2 colons, this will give us the whole array. But if we say we want start blank, so that's going to just default to the beginning. Stop is going to default to the end. And 2, that will give us alternating elements of the array. So the first, the middle, and the last. If we want the first 3 elements, and we've seen this notation before with lists and strings, we can specify we can leave this first part blank, so that's the beginning to 3, so that'll give us the first 3 elements. And if we want starting at element 3, we can get the last 2 elements. In fact, we can also do so these are all kind of different flavors of ways to get what we want. Oh yeah, I already had that. See, I get ahead of myself. So if we want just the last element, we can count backwards with a -1, or we can, again, we can say we want from the third to last element up to the end, so we get the last 3 elements. And so this works the same way for multi-dimensional arrays. So just like with before, we use a comma to separate those dimensions. Here we have a Numpy array, and we used a list comprehension to make this. So we said we want n plus m times 10 for n in, and here we're using the old range function, range 5, for m in range 5. So this is a double list. This is a list comprehension inside of a list comprehension. So that's going to give us a list of lists. We're going to convert that to an array, and this is what we get. So you can look at that and figure out what's happening. But this is just a double list comprehension. There's no NumPy stuff in there, but then we're converting that whole thing into a NumPy array. And then we can pull out blocks from this. So let's say we want from 1 to 4 and 1 to 4 both the rows and the columns. So this is going to give us these rows from 0, 1, 2, 3 to 4, and these rows and these columns. So it's going to be 0, 1, 2, 3, and then removing 4. So we're going to get just this middle section of this array. So we're doing a double two-dimensional indexing. And we can also do this strides thing. So we can say we want every other element in both dimensions. And so it's going to give us just the outer, or just the middle, the outer and middle rows and columns. Another another way we can do this is by specifying a list to be the indexes. So this allows us to say we'll see this a lot, and this is kind of what's happening under the hood, but we maybe don't always realize it. But if you want a like we'll see this in pandas, where you want the subset of a data frame. So let's say you have a data frame that has precipitation data for the whole year, and you only want the precipitation data for 1 month. And your data frame has a column for the date. So you can say the date is in October, and that's a logical statement. It'll either be true or false for each row of your data. And then you can say, I want the whole data frame, but only the rows that have that value as true. So you're basically saying these are the indexes that will either be, these are the rows that will either be true or false, and then I'm going to pull out those rows from the data. So the same thing we can do sort of numerically here. We can say I want indexes 1, 2, and 3, row indexes 1, 2, and 3, and then A I'm going to pull out from that list, and it's going to give me rows 1, 2, and 3. So I'm just substituting in those positional indexes. Similarly, I can, if I wanted to, I could take this whole list and use it twice, or I can use the row indices here and the column indices here. So I have these 3 rows and then these 3 columns. So the same thing works also with what we call masks. This is what I was just talking about, where you have a true or false or a Boolean value. So if it's true, it will give you that element. If it's false, it won't. So we have this array B, which is just 0, 1, 2, 3, 4. And then we have this mask. It's called row mask here, but it could be called anything. That's an array true, false, false. And we're going to index, we're going to index that array using this other array of Boolean values. So it's going to give us only the elements where, when we match up those 2 lists, that the second one is true. And we're not going to get any elements of where it's false. So we're going to get, is this first position true? Yes, so we get 0. Second position, that's false, so no. Third position true, so we get that one, not the other 2. So we end up with a subset using this true-false operator. The same thing can be done if we convert we can convert a list of integers to Boolean. It will just automatically convert those to true or false. Question?
I held up on the first fancy indexing thing.
Mm-hmm.
I don't understand why it doesn't give you a 3 by 3 array instead of, it just gives you 11, 12, 34. Like, I thought it was going to give 11, 12, 13, 21, 22, 23.
Right. So what we're doing here is we're passing so we're not doing slices, we're doing positional indexes. So it's giving us, let me see if I can I don't. This is adding. I feel like this is adding more complexity that we don't need right now. It's the same thing. I didn't change anything. I just changed how it's. So what it's saying is, we have these row indices. If we just pass the one set, we're going to get rows. But we've passed two indices. It's just like passing. So this is equivalent to A 1 1 A. I'm not sure how we could. Yeah. So it's basically matching up those indices. So if we had done that, I'm guessing this will give us an error. Yeah. The indexing arrays need to be, so it's called broadcasting. It's similar to like when we did that zip function where we take two lists and we kind of zip them together, or it's called broadcasting, where we're saying I want the first element in the first list and the first element in the second list are going to be the two coordinates for that array.
Is there a way? Is there like another argument you can give so that it would give you the full 3 by 3 rather than?
Yes. So if we want the full 3 by 3, we would do one. We would do what we did. Yeah, what we did before. Here. So another the way that this comes in handy is, so here we just specified true false kind of arbitrarily, right? But if you want to apply a test, this allows you to do that. Masking allows you to do that. So here we have an array that is 0.51 all the way up to 9.5. So let's say we want all the values in that array that are at least 5 and have no decimal component. So we can say this mask is going to be an array that's a true-false mask, or I think this will actually just be a list, but it's let's see, it is an array. Okay, so this mask will be an array that will be true if x is greater than or equal to 5 and the modulus of x, modulus 1, is 0. It will be true. Otherwise, it will be false. So this is going to be an array that has true, false, and then we're going to say we're going to take this array and this mask or array of booleans, and we're going to use that second array as the indexing for the first array. So this will then only give us the values that are more, 5 or greater and have no decimal component. This could be used for anything. So for example, all the time in data analysis, I will take a data frame. The same thing works in pandas. We'll see. You take a data frame, and then you say, another way we could do this would be x where x is greater than 5. So this is a really easy way to get a subset of the data and then move ahead with that.